Hello Techie guys, welcome back to Techie Uday. In our last video, we have seen what is the body recursion. In this video, we are going to see what is the tail recursion and understand how the execution works when you call a function using a tail recursion. Let's see what it is. What is a tail recursion? You call a recursive function as a last statement of a function. That is, there is a pending action once you called the recursive method. It is like you call the recursive method at the end or the last step of your function. That is what the tail recursion means. Let's see an example here. In this example, you are calling a function. This is a base case, n is equal to 0. You are printing an value called accumulator. What the function does? This function adds n values using an accumulator, using the tail recursion. See, the output you can see is like for the argument 5, like 1 plus 2 plus 3 plus 4 plus 5, the value adds up to 15. So that is the output of this function. Let's see in our IDE what actually the demo tail recursion I am calling that. Now if I debug it, it is expecting one more argument 0. I am passing it out. Initially the sum of 0 is 0. Like I am passing an accumulator. This accumulator is to add up all the n values we are passing to that method. Initially, the sum, we take it as 0. Now, when you debug this, what actually happens? You put a debug point here and let's run this. Now, initially, the n value is not 0. If you see the recursive stack here, the same way as I explained in my previous videos, this is the recursive stack builds up. Now, the n value is 5. It is not 0. So it's not a base case. It went to the last statement. What is the last statement? It is calling the n-1 with accumulator value as accumulator plus n. What is the current value of n now? Current value of n is 5. So current value of accumulator is 0 and current value of n is 5. So now for the next recursive call, for this recursive call, the n is 5 and accumulator is 0. And when we continue, for this recursive call, n is 5 and accumulator is 0. And for this recursive call, n is 4, but accumulator is like 5 because when you were calling this method again, you decremented n by 1 using n-1, you incremented accumulator by n using accumulator plus n. So now for this function call, the n value is 4, but the accumulator value is 5 and n value is not 0, it still continues. And for this recursive call, n value is 3, accumulator is like 5 plus 4, 9. And still continues. For this recursive call, n value is 2, but accumulator value is 13 because 9 plus 3, 13. And for this recursive call, n value is 1, accumulator value becomes 14. So what we are doing in the recursive call, we are actually adding up the values. So the point when you reach the end, we'll use that accumulator value as a sum. So in what cases this tail recursion works? This tail recursion works when you are taking some cumulative actions, like you keep track of something till the end. So in those cases, we can use this tail recursion, like we are keeping the track of the sum. In the same way, you can keep the track of products. So you can keep the track of some counts. You do some actions. You perform some predicates here. So this is how it works. It keeps the track of some reducer function. You can use some reducers while you're solving some problems using this. You understand much more deeper. For the simplicity, I have taken this example to make you understand what actually the tail recursion is. So now n equal to 0, the base case has come, and now what happened? It prints the accumulator and that's done because you have completed the function. Calling the recursive function is the last step. There is, after this step, is nothing. All the functions pops up from the call stack because there is nothing left to execute. So that is what the tail recursion means. The tail recursion is almost like a single flow. When you perform operations, there is nothing left to execute further. So that is what the tail recursion comes in. Few languages like Python or C optimizes the code for tail recursion. When you perform the body recursion or head recursion, it may keep the memory, but some of the languages, of course Java may not optimize your code for the tail recursion, but the other languages can support the tail recursion optimization. If you observe, In our previous video, we have taken this tail recursion example. When you perform the Fibonacci series, you are using the tail recursion here. The tail recursion is the very last step of a function call. So when you call Fibonacci of n-1 and Fibonacci of n-2, this is what example of tail recursion. But it is possible to convert this as a body recursion using a is equal to Fibonacci of n-1, right? In this way, you can do it is returning the long, so make it as long. Long is equal to Fibonacci of n-1, long b is equal to Fibonacci of n-2, and finally you are returning a plus b. So this turns into a body recursion now because you are first calculating the n-1 sum and then updating the value of a and going for n-2, updating the value of b, and finally you are returning the values a plus b. So you are taking the sum of the first two calls, that it becomes the body recursion. So based on the place where you are calling the recursive function, we term it as a type of recursion. It's like a head or body or tail. So based on the place you call a function, it treated as a specific or respective function. So that is what the head recursion, body recursion, or the tail recursion meant for. There is another type of recursion like indirect recursion. We will see that in our next video. Hope you enjoyed this video. If you like my explanation, like this video right now and subscribe to my channel for more interesting videos like this. Hope you enjoyed this video. Thank you for watching. Meet you in the next video. Have a good day. Bye bye.